All right, take your homework out. You had just 2 problems to do for homework. First, you were supposed to graph this function of x. F of x equals 2 times the cosine of x. And for starters, as you graph, let me make sure I get those labels on there as well. For starters, you would want to start with your key points of cosine, which are, class?
0.
No.
1, 0, 1,
negative 1, 0, 1.
Make sure you memorize these. 1, 0, negative 1, 0, 1. But because of the 2, which changes the
value,
it's going to cause it to go higher above the x and lower below the x. We call it distance above and below the x-axis. Starts with an A.
Yeah, amplitude.
Amplitude. We're going to change the amplitude of the curve. And of course, that's going to change all the points, but particularly the key points.
2, 0, 0.
And if you were in a real hurry, those are perhaps the only points you would plot. You just do your best to be as accurate as you could be, knowing that I'll be nitpicking when I'm grading it. However, if you had a little bit more time, you would double the other values. Like normally we'd have a 1 right here, and next to the 1 we'd have a square root of 3 over 2. But if you multiply that by 2, you just get the square root of 3, which is about 1.75, and you'll put that all around your 2's. 1.73, excuse me, close enough. And then also you normally have near the zeros, you'd have half and negative half. But when you double that, it's 1 and negative 1. You can plot those points as well, and you'll just connect the points with a smooth, continuous curve.
Do you normally do those 0.5s and stuff? Like, if you were doing this on your own time, then again, you're like, you've done this so long, you probably don't have to. So
if you were doing this for a grade, you would. Put it that way.
Would we lose points if we didn't? If it was right, would we take
Oh, yeah, as long as it went through that point, whether or not there's a dot there doesn't matter, as long as it's accurately going through. Correct, is the idea. It just has to be accurately going through the key, those values. But no, I mean, if I don't see a dot, as long as it's going through the correct spots, I'm not going to take points off. And again, my recommendation, if you struggle making a smooth curve, be very lightly trace the curve first, and then very lightly get what you want, like an artist kind of doing an initial sketch, and then go back and retrace over, and maybe erase any of the fuzziness that forms around the outside. But how many in a graph that looks like this for your first one? All right, questions on that?
Mine would like.
All right. Now, of course, it would keep going if we wanted to. We could keep going, right? And it would just keep going and going and going. So we say that the domain of the curve class is?
Or infinity. Negative infinity to infinity.
All real numbers. Negative infinity to infinity. We said that the range is going to be?
Negative 2 to 2.
Negative 2 to 2 because we doubled it. Normal cosine would be negative 1 to 1. Here, the range is now negative 2 to 2 because we doubled everything. The period of the curve?
2 pi.
2 pi. By the time we get to 2 pi, we finish one complete cycle. We can then start the next cycle and go from there. We also said that cosine is an even function because it's symmetric to the y-axis. Also, the negative mirrors the positive, okay? So it's an even function. Let's take a look at the other graph that you had to do for homework. Yes, sir?
Is the idea the same thing for wavelengths and stuff like that? Like for like sound and stuff?
Yes, sound is a sinusoidal curve. It will follow this type of wave pattern. We'll talk about that in physics. All right, let's go and take a look at f of x equals negative 1.5 sine x. And a couple things going on here. First of all, what does that negative do to the graph, Ethan?
It starts in negative.
It's going to, anyone? Flip it. What's the word? Invert.
Yeah.
It's going to invert the graph, and then here the 1.5 is also going to change the amplitude.
Yep.
So we have an amplitude change and an inversion happening. Now normally sine's key points are going to be what, class?
0, 1, 0, 0.
But we're going to multiply all of those by negative 1.5 to get negative 1.5 here and positive 1.5 here. Again, I would start just with those key points. You've got a 0, you've got a negative 1.5, you're back to a 0 at the next quadrantal, then up to 1.5, then back to 0. The halves have to also be multiplied by 1.5. So if you took a 0.5, multiplied it by 1.5, you end up with like 0.75. So where I would be just below here, I'm going to go down to 0.75, down to 0.75, up to 0.75, up to 0.75, and then if you took a square root of 3 over 2, maybe do this on the calculator real quick, square root of 3 over 2 times 1.5. Square root of 3 over 2 shrink this in a little bit.
299.
Well, I'm sorry?
1.299.
1.299, like basically 1.3. So here's the 1, here's 1.5, here'd be about 1.3-ish. Okay? And we can plot those points as well. And then we'll connect with, to the best of our ability, a smooth.
I forgot to flip it, but I would have had the right answer if I flipped it.
And that's going to be where big points, again, neatness, little points, remembering to flip, remembering to stretch, those would be the bigger points there. How many did have a graph that looks like this? All right, he already figured out what he did wrong. Question, Quentin.
I did the cosine instead of sine.
Okay, so yeah, make sure to pay attention to which set of key points we're using, whether sine or cosine. Turn in your textbooks, if you would, please, to page 84. Turn in your textbooks to page 84. Now, we're not going to graph all of these, but I just want to kind of run through a check. As we look at different functions, can we spot inversion? Can we spot amplitude changes? Because that's what we're going to be looking for. On page 84, numbers 1 through 12, again, we are not going to graph all of these. But as we look at number 1, it says to state the amplitude of each function. And what is the amplitude for number 1? Ethan?
3.
3. How about number 2? Jamie?
4.
4. Number 3? Quentin? 1/6. Now remember, every one is 2 boxes, right? So to go 1/6 of the way would be 1/3 of the way up the box. That's as high as it goes. 1/3 of a box. That'd be nasty to try to graph.
I want to see you try and graph.
No. All right, number 4. What do we got here, Chris?
Negative 3/4, so inverted.
Right, inverted and then a 3/4 amplitude. Amplitude doesn't really have an SIGN, right? Amplitude is just how high and low. So the amplitude's 3/4, but you're right, we also invert. So a little bit shorter graph on that case, but not nearly as bad as the 1/6. Number 5, Ethan.
It's an amplitude 1.5.
1.5. How about number 6, Jamie?
2.5.
Number 7, Quentin.
3.
3, and we're going to invert it. Ignore the 2 in front of the x for now. We're going to talk about that here in just a few minutes. Number 8, Chris.
2.
2. Number 9, Ethan?
0.57.
0.57. Really random
It's
there.
about at the 1.
Yeah, that 0.57, I'm trying to think, are they going for like pi over 3 or something there? I don't know. Pi over 6. I don't know. Anyway, what is pi over 6? Plug that in your calculator.
0.5235.
0.52. So no, that's not good. It's just a really random number, 0.57. Number 10 is also pretty nasty, Chris.
0.33.
And we know that's pretty much 1/3, right? That's not too bad, I guess. And then the 0.57 is a little bit more than 1/2. And we could kind of estimate graph it. And technically, we're estimate graphing anyway, right? So we're not actually finding 2 pi. We're putting it at 6, which is close, right? Number 11, what's the amplitude, Jamie?
1.
1, but we're also going to
Flip
it, invert it. And then number 12, what's the amplitude, Ethan?
1.
1 also. And then there's that 9 that's going to mess some things up that we're going to talk about in just a moment. All right, at your seats, I want you to set up a taller graph grid than normal as we graph f of x is equal to negative 4 cosine x, or as you graph negative 4 cosine x. And I'll put it up on the board in just a moment. F of x equals negative 4 cosine x.
pi over 3, right?
Sorry?
So like when you're finding, so I already have all the big main points. So for the ones that
Yeah,
have assigned,
let's hit those main points again, class. Cosine, what are the main points?
1, 0, negative 1, 1.
Normally, right? Now, what's always next to the ones?
0.9.
0.9, but it's really square root of 3 over 2 if you want to be a little bit more accurate, right? And that's going to be on either side of the negative 1, on the other side of the 1. What's always near the zeros?
0.5.
0.5 or a half. So those are your other points that you want to kind of keep in mind there.
Messed up.
Neatness, Chris. Neatness. Take your time. Slow it down.
It's pretty neat.
Nice thing is, half times 4 becomes 2's. So you're going to have a 2 and a negative 2, a 2 and a negative 2. Excuse me, that should be a negative 4 right there. The square root of 3 over 2, when you multiply that by the 4, ends up giving you like 3.5 almost exactly. 3.6. Okay, so or in this case, it's going to be negative 3.6, and of course positives and so forth. So I plotted the points, and I started top down. That's just a strategy tip you might want to use, especially when it's coming so high and so low. Okay, you might remember when we graphed parabolas back in Algebra 2, I said, don't start here and then go to the curve and down. Start at the curve of the parabola and come down. A similar idea here. So I started here and I came down and I ran through. But then for this part, I wanted to get the same curvature. So watching, what I did is that if you went back and watched the video, you'd see me start here, not here, to go down the other side. So I can retrace the curve and kind of feel that curvature and make sure I replicate that on the other side and then down. And notice you want to come almost like you're coming in straight at the end because you're about to reverse course if you kept going. So coming in straight at the end. So not coming in like this, but coming in where at the end you're almost going straight where you could reverse course if you had to again. So a couple little drawing tips there. All right, so what we've done so far, we flipped, we've stretched, and if I had something obscene like a 1/4, we would smush, right? But we can do other things as well. We could also stretch it out this way or smush it in this way by changing the period of the curve. That's the next section in your notes. Changing period. Changing period. Obviously, the period of the curve is normally 2 pi, right? But if I stretch it out, if I make the graph take, say, 3 pi before it finishes, or 4 pi before it finishes, that's just stretching it out wider, correct? Or if I smushed it, I said, no, you need to be done by 3 pi over 2 or by, 7 pi over 4 or what have you. I can make it get done sooner. And then if it's done sooner, that smushes it in. So changing the period is essentially horizontal compression or stretch. Or I'm going to write horizontal stretch or compression. What amplitude does vertically, the period change does horizontally. This is a horizontal stretch or compression that will take place. So we're familiar, right, with your base sine function, right? But we said technically there's an understood either positive or maybe a written negative. There's some number, and it could be a 1 in front of the sine curve. But we saw this a moment ago in our problems. We saw a number in front of the x. We're going to represent that with the letter b. So by way of review, if there's a negative, class, that tells us to invert. Think flip, right invert. So positive, negative, do we invert, do we not invert, right? A, of course, is our amplitude, which again will vertically stretch or compress the graph. The actual function itself is what's going to tell us the basic shape. And of course, this is where we get our key points from, is from whatever trig function, whether it's sine or whether it's cosine. But the b is what we want to address now, and I need to give myself a little bit of room for this. The b is going to change the period, because the period of both sine and cosine is 2 pi over b. Now, I've been saying the period is 2 pi. Well, that assumes there's a 1 in front of the x. We would have thought before that assumes no number in front of the x, but of course we understand if you see no number, it's an understood 1. Really, the period is 2 pi over b. And so as we change that b value, we will change the period of the graph. Here's another way to think about the b. And if you put a star next to this, b is the number of full cycles by 2 pi. If you graph from 0 to 2 pi, the b tells you how many full cycles of the curve you will see. Normally it's a 1, meaning we normally see 1 full cycle. But consider this for just a moment. Write this down in your notes, and we're going to graph it here together. F of x equals the sine of 2x. Well, seeing that 2 right there is going to change the period, isn't it? How many full cycles should we see? We should see 2 full cycles. Because of the 2 here, between 0 and 2 pi, because the period is going to equal what?
2, 4 pi.
Careful. The period is 2 pi over b.
4 pi over b.
What is b?
2.
2. So 2 pi over 2.
Pi.
Pi. The period just equals pi. Or if you wanted to, so you'd remember in your notes how you got that, 2 pi over 2. Right? Because that's the b value. So let's go ahead and take a look at what this would be if we graphed it. We'll expand the screen here just a little. I'm going to set up a graph grid. Now notice there's no amplitude change here, so this is still only going up and down 1, -1. So we don't need a particularly tall graph grid, which is awfully nice.
We love that.
We do. Less graphing is less graphing. As lazy mathematicians, we can appreciate that.
You're teaching us to be slobs.
To work smarter, not harder, is actually the way I like to think of it.
Yeah.
I'm not teaching you not to work, I'm teaching you to work smart ways.
Yes. Precisely that.
So let's consider this for just a moment. If the entire period is pi, then that means all the key points, class, have to be done by the time you get to pi. Now, what are sine's key points?
1, 0, or -0, 0, 1, 0, -1, 0, -1.
All of this by the time you get to pi. So here's the way I graph it. I put my first point, of course, at 0, which is 0. And I put my last point at pi, which is also 0. So I start by checking off the first and last points. Then I'm going to plot the middle of the two, which is another 0. So I'm going to go right in between 0 and pi, which is, of course, pi over 2. And right here, I put this 0. Now, exactly halfway in between these two zeros, I've got to put a 1. Halfway in between is actually going to be right here in the middle. And then halfway in between the last two zeros, I put a negative 1. And here, I'm going to kind of deviate away from putting all those extras. I'm just going to try to trace a nice rounded curve up, down, and back up. Let's kind of retrace that, and then I'll erase the ugly there that I started with. And that's our sine curve. And you notice it's been smushed in because I have the whole thing having to be done by the time we get to pi. Now, if I were to graph the second cycle of it, I'd have another 0 3 boxes later, another 0 3 boxes later, a 1 between those, a negative 1 between those. And we can see 2 full cycles of the sine curve by the time you get to 2 pi. Questions on that problem?
Would you have to show the second one to be right?
It depends on the instructions. If the instructions say graph from 0 to 2 pi, you do the whole thing. Normally, I'm wanting to say quiz and test instructions will say graph 1 full period, in which case you would only graph to pi. Though I would mark off if you went further, but you just have to graph between 0 and pi. I think that's usually the instructions, is graph 1 full period, not graph from 0 to 2 pi. For some reasons you'll discover as we move forward. All right, questions on this? Let's do another one. Write this one down if you would. F of x equals the cosine of 3x. Oh boy, how many full cycles, class? 3 full cycles between 0 and 2 pi. What is the period of the curve going to be?
2 pi over 3.
2 pi over b, which is 3, so 2 pi over 3. Now here's the hard part. You don't see where that is on there, right? But let's think practically. What's the reference angle? 60, right? Anytime there's denominator 3 is reference angle 60, and we're in quadrant 2. It's a little less than a whole pi, right? So we know we're going to be reference angle 60, quadrant 2. So what is the 60-degree angle in quadrant 2? Or multiply by 180 over pi. Okay, you can do that as well and cancel the pi's out. Either way, you get 120 degrees, which may actually help you, because remember we said every box is essentially 30 degrees, right? 0, 30, 60, 90, 120. That's the stopping point. The entire cosine curve has to be done by the time we get there. All right, so I'm going to switch to the white chalk, since I've already used the orange chalk. And let's see, what are my key points of the cosine curve?
1, 0, negative 1, 0, 1.
All right, so that means we're going to start at 1. I'm going to put an X here. And we're going to end at 1, which is 4 boxes later. Halfway in between, we need to have a
0.
Nope. Between the 1 and the negative 1, halfway in between needs to, or between the 1 and 1, halfway in between needs to be a negative 1. Halfway in between, this is 4 boxes, so 2 boxes down to negative 1. And of course, in between the 1 and negative 1, we need a 0. And then again, between the negative 1 and 1, we need a 0, which is going to be here. So basically, yeah. Now again, resist the temptation to just make a V, right? You've got to actually curve it down. It's going to come down pretty steeply. But it's also got to be able to reverse course to go back up. And our cosine curve, you see the same shape we had before, right? It's just really smushed in. And again, if it said graph one full period, we've done it. If it said graph from 0 to 2 pi, we do the same thing again, right? We go to the next box, will be a 0, the next box a negative 1, the next box a 0, the next box positive 1. And there's cycle number 2. And then 0, negative 1, 0, 1. And we can see by 0 and 2 pi, you get exactly 3 full cycles. Questions on that one? Come in just a little tighter. On YouTube, give the chance. Hopefully it's not too fuzzy the more I zoom in, but hopefully you can see that there. Write this one down if you would. F of x equals the sine of half x. I just made my YouTube audience throw up with all the zooming I just did. All right, sorry about that, guys. F of x equals the sine of half x. And this means we'll have how many full cycles by the time we get to 2 pi? Half. Half a cycle between 0 and 2 pi. Because the period is going to be what? 2 pi over? 2 pi over a half. Well, we never really divide fractions. We multiply by the reciprocal. If we take 2 pi and multiply that by the reciprocal, we would get 4 pi.
Oh boy.
So my period is going to be 4 pi. All right, here we go.
All right.
Now, you're going to want to draw a longer x-axis than usual, because normally we go to 2 pi. Now we need our x-axis to go all the way out to 4 pi. So, lengthy.
I don't even know if I have enough room on that for my paper.
X-axis. If you started further back, you started like in the middle of the page with your y-axis. If you put the x-axis toward the, or the y-axis toward the edge. All right, here's the fun part. Line this up. Well, not too great.
Could be worse though.
Horizontally it worked well, but there's that vertical mesh point that didn't turn out so good. All right, it's okay. We'll roll with it. So we've got our f of x-axis, and then the x-axis. All right, we've got pi over 2, pi, 3 pi over 2, 2 pi. What would be next?
2 pi over 2. 5 pi over 2.
We got 1 pi over 2 pi, 3 pi over 2, 2 pi, 5 pi over 2 would be 3 boxes later. And then 1, 2, right here, I guess would be our 3 pi. And then 7 pi over 2, and then 4 pi. Here we go. All right, so 24 boxes over. I guess there are only 12 boxes to the 2 pi, right? So 4 pi would have. Now, by this time, I will say this. We're a whole box off by the time you get to 4 pi, right? Because at 2 pi, you're half a box off. Now, we're going to be a full box off, but, you know, whatever. If you're going to be off, just be off and embrace it, right?
I didn't do it long enough. I thought I did.
All right, so 1, -1. That's as high as this graph's going anyway. So what are my key points of sine, class?
0, 1, 0, -1, 0.
So we need to start at 0, and then all the way over at 4 pi, we need to end at 0.
Yes.
All right, halfway in between, we need another 0. And halfway between 0 and 4 pi will be 2 pi. So go to 2 pi, put a 0. Halfway in between the first two zeros, we need a 1. Where is halfway between the 0 and the 2 pi? Pi. So at pi, we put a 1. And then -1, I'm going to plot at the 3 pi. Alrighty then.
Let's go.
So normally the very box next to the 0 is the half, right? But we're pushing everything out doubled, right? Instead of 2 pi, it's all doubled out to 4 pi. So instead of 1 box over, 2 boxes over, put your half. And then 2 boxes before this next 0, put your half. 2 boxes after the 0, put the -half.
Wait, what?
And 2 boxes before the last 0, put your -half. So instead of 1 box to the half, 2 boxes off the zeros. And our 0.9s were normally next to the 1. You're going to have to come 2 boxes away from the 1 to do your 0.9s, and 2 boxes away from the -1 to do the -0.9s. Now, it's not as critical to get all these extra points when the graph is smushed. There's less margin for error. Chris, plot the points with me. You're trying to go ahead and you botched the whole curve. Do it with me. Learn. All right, so do we see how I plotted all of them? Instead of 0, half, 0.9, 1, it's 0, come over 2 boxes, half, come over 2 boxes, 0.9, come over 2 boxes, 1, come over 2 boxes, 0.9, and so forth. So that when you connect all those dots, you get a very slow sine curve. It's still a sine curve. You can just see it's been stretched out along that x-axis. But same basic shape. It's just, you know, it's like driving from here to Opelika, you know, where there's rolling hills along there out to Smith Station, but it's not quite like, you know, driving up and down mountains or anything, which is, you know, maybe what we saw with the last graph we did, where it was up and down really fast. Okay, this is more gradual, rolling hill. What?
Are hills on the way to Opelika?
A number of them. Though if you go to Opelika, they've leveled the roadway for the most part, but coming back is the original road they put in. Like they had the original 2-lane highway, and that is up and down like crazy. And then they built another highway, and they leveled it off, and they made 2 lanes each way. And the leveled off is going there, and then it's good on gas mileage, and coming back is bad on gas mileage. But anyway, I digress. Questions on this? All right, so look in your books there at page 84. Most of you still there. Let's take a look at page 84, and let's see if we can state the period of each of these. We're not going to graph them all, but let's just find the period on numbers 13 through 24. Number 13, what's the period going to be, Quentin?
5.
Well, the number is 5, the b is 5, but the period's 2 pi over b, so
2 pi over 5.
2 pi over 5, which isn't even, like, we'd have to figure out, estimate where that would be if we were to graph it, but we know this, we're going to get 5 full cycles between 0 and 2 pi, which is really fast up and down. How about number 14, Jamie? What's the period?
Would be the 2 pi over 0.4.
Good, 2 pi over 0.4. Now let's move the decimal over in the bottom to get a 4, and move the decimal in the top, so instead of a 2 pi, it becomes a 20 pi. So it's 20 pi over 4, which becomes
5 pi.
5 pi. So we'd have to extend that out all the way to 5 pi if we wanted to graph that next one. How about number 15, Ethan?
It'd be pi over 3.
Pi over 3, good. 2 pi over 6 reduces to pi over 3, which is 2 boxes. So the entire cosine curve done in just 2 boxes. Very, very short. Number 16, Chris.
2 pi over x over 5.
Well, not the x. Okay, remember the x isn't part of it. The b is the coefficient of the x. So what is being multiplied by the x here?
5. So
The 5 is being divided. What's being multiplied? This is tricky. Remember in Algebra 1, I said if you had like a 2/7 x, move the x to the top and make it 2x over 7. So if you saw 2x over 7, you knew the coefficient was 2/7. Well, here we have an x over 5. What's the
1 over
coefficient? 1/5, right? Here b is a 5th, so my period is 2 pi over 1/5, but multiplied by the reciprocal. What's my period?
10 pi.
10 pi.
That's
So again, aren't you glad we don't have to graph it, right? It's not quite that bad, but yeah, we've extended the x-axis all the way out to 10 pi just so we can
I want to
graph
see you
that.
graph it. I'm joking.
We're not going to, on purpose.
The whole board.
It probably would. Number 17, back to Quentin.
2 pi over 2.5.
Good, and the same thing we did with Jamie, let's move the decimals over to make it instead of 2 pi over 2.5,
4 pi over 5.
20 pi over 25 becomes 4 pi over 5. Good, which is just a little before you get to pi, the whole curve would be done. Number 18, Jamie.
Would be the 2 pi over 4.
Which reduces to?
Pi over 2.
Pi over 2. So by the time you get to pi over 2, the whole graph is done. Number 19, Ethan. Pi. The whole graph is done by the time you get to pi, and you have to stretch it all the way up to 11 and all the way down to negative 11. So you're smushing it in and really stretching it out. Number 20, Chris.
Pi over 3.
Pi over 3 and stretching it vertically 3. Number 21, Quentin. Oh, you don't need a calculator, do you, Jamie? Jamie's got this. What is it, Jamie? You don't know, Chris?
2 pi over 1.
It's 2 pi over 1. It's just 2 pi. Don't let the amplitude throw you off. What's in front of the x is a 1.
I was looking at point.
I know you were. That's the whole reason they did that, was to see could they trick you. Don't get thrown off by the amplitude. Good, Chris. Focus in on the b, and it's a 1, so 2 pi over 1. So let's see, number 22. Let's go back to quantity for redemption. What's the period? 2 pi. Good, not fooled twice. Number 23, Jamie.
2 pi over 5.
2 pi over 5. And then number 24, Ethan.
It is hold on. 4 pi? Hold on.
Might help to actually write something down. That might make life easier. Scribble it on paper real quick. Well, he's got the 2 pi over 1.5, and then he's moving the decimal. He got the 20 pi over 15, and he was trying to reduce it down. He just needed to see it.
4 pi over 3.
4 pi over 3 is the answer there. Good. Questions on finding the period of a curve. And again, the key is once you find the period, put your starting point, ending point, halfway between those, and get those points down. So let's do a little of it all though, right? Because we can now not only change the period, we could also change the amplitude at the same time, and we could invert it at the same time. So write this function on your paper, on your graph paper. F of x. F of x equals a negative 3 sine of 1.5x. F of x equals negative 3 sine of 1.5x. F of x equals negative 3 times the sine of 1.5x. There was a problem, by the way, on, I think it was either the ACT or SAT prep that involved sine and cosine with amplitude changes and things like that. And I said, we're going to get there, but you hadn't learned it yet. Well, now we're there. So just in time for your ACT and SAT coming up a little later on this month. All right, so first of all, let's start with our key points. What are my key points normally for sine class?
0, 1, 0, negative 0.
But this time, those are not going to be my key points. What are they going to be now, class?
0, negative 3, 0, 3, 0.
All right. Still start by adjusting your key points with amplitude and inversion. But now let's take a look at the period. What is the period going to be?
4 pi over 3.
4 pi over 3. Now let's figure how many boxes that is. Let's make this into what you call degrees. Let's multiply by pi, or 180 over pi. You can use your calculator if you needed to.
Oh, 240.
240. 4 pi over 3, not 3 pi over 4. So 240 degrees. Now remember, every box is 30 degrees essentially, right? We don't label it in degrees, but it's basically 30 degrees. So how many boxes?
6.
30 degrees divided by 30. 8 boxes.
8.
All right, so we're going to do all of this in 8 boxes. Make sense? All right, so when you draw your graph grid, make sure you give yourself room to go to negative 3 and 3, and give yourself room there for your amplitude. Give it just a little bit there on the camera. Now, last year, Melvin had to do all of this distance learning. Okay, so he didn't get to be in the classroom watching. He had to watch it on YouTube, and then we did some Facebook video chat. I did it like under the document camera on graph paper, but definitely easier to learn this when you're in the classroom. There's also a large graphing portion in the 4th quarter, which in the original COVID year, all my pre-cal students had to learn all of this from the document camera. And y'all remember, it wasn't a crystal clear image you were getting. It was a little fuzzy.
Did they do good?
A couple of them did really well, and then there were a couple who really struggled with the transition. Let's put it that way. All right, so yeah, be thankful that you are in a classroom learning this, because this is I've had a lot of trying to teach graphing concepts through remote, and that's just not ideal.
We're working with it now.
Alright, so pi over 2,
Someone knock on wood.
3 pi over 2, 2 pi. Alright, so our 8th box is where we're going to stop. So I'm going to put what at the 8th box?
0.
A 0. And of course, I'm also going to put, there's 6 boxes, 8 boxes. I'm also going to put a 0 at the
Origin.
very beginning, at the origin. Good. Alright, so we start at 0, we're going to end at 0. Halfway in between, we also have a 0. Basically, if it's 8 boxes total, go over 4 boxes, and there's your 0. Now, in between the first 2 zeros, I'm going to need -3. So that's 2 boxes over. I'm going to go all the way down to -3. And then in between the last 2 zeros, I'm going to go all the way up to +3.
This is going to be funky.
All right, so again, my suggestion would be start at the top of the curve, and curve your way down. And you have the advantage of being able to flip your paper over. Here's what I would do. I would flip it so that this is up, and I would come down from that. I don't have that luxury. I'm going to have to try to come up from it because I can't exactly flip my chalkboard. And then as you need to, go ahead and doctor up the curve to make it look just a little bit better.
I wish I would have done this in pen.
It does help to have pencil, it's true. And obviously on graded ones, you'll do them on separate grids, so you're not using multiple, different colors of pen and all on the same grid kind of stuff.
Imagine you had an exam and instead of like a big essay or something, you just made us do like graph 10 pi or something.
I'd kill myself.
I wouldn't do it. I just lose the -6.
Probably be like -300.
Right, something like that. It's not perfectly graphed. I didn't take time to figure all the extra points, but a pretty close approximation of what it would look like. Again, if we wanted to go all the way out to 2 pi, I guess that'd be 4 more boxes. I'd be able to do half of a curve, which would be, let's try coming all the way down there. Something like that, if I were to finish between 0 and 2 pi. Yeah, there we go. Questions on this? Do you see the approach though?
Yes.
Key points, what's the period, start to finish, go halfways again. Let's do one more, and then we'll be done for today. F of x equals 2 cosine 2x. F of x equals 2 cosine 2x. I'm going to go orange here. First things first, always start by key points.
1, 0, -1, 0, 1.
But take care of amplitude and period change, or amplitude and inversion next.
2, 0, -2, 0, 2.
Then figure your
Period.
period is what?
Just pi.
Pi. 2 pi over 2, or just pi, which is nice and easy because I can see pi on the graph already. Whereas last time I kind of figured, okay, how many boxes is that? You can see pi. So I'm going to start class at 2, and I'm going to end at pi with another, nope, at pi I'm going to have a 2, the last 2. Halfway in between, which will be pi over 2, I have to be down at -2. Halfway in between these, I'm going to be at 0. Now, halfway in between is going to be right here, a box and a half over. And then the other halfway is going to be right here. Again, don't go straight V. You're going to have a little bit of curvature down. But it does drop pretty quickly. You're going to have to reverse course. Something like that.
Yeah.
All right, of course, we could fit a second one of those if we really wanted to, I guess. Do we want to? Sure. Why not? Something like that. Of course, you can see the 2 complete pi's. It makes a nice W. So, we could spell somebody's name if anybody in here had a W in their name, but...
Wait.
Yeah, he doesn't even know his name. Okay. My son Andrew. There we go. There's the W. And if we rotated it sideways, you could kind of think of that as an E. I don't know. Anyway, we'll learn all kinds of different graphing stunts and stuff we can do later with different functions, and you could spell your name out on a graph grid if you wanted to really badly one day. Questions on this? Do we understand not just amplitude and inversion like we talked about yesterday? Do period changes make sense?
Yeah.
All right, I have one problem for you to do for homework tonight. I know it's a Wednesday, but one problem won't kill you, and it'll keep you practicing this so tomorrow you won't forget everything I just taught you. So for homework, you're going to graph f of x equals negative half sine of 2x. Negative 1/2 sine of 2x.
Oh.
Your exam is in lesson 44. Your exam is in lesson 44 that's coming up on Tuesday. The plan is that tomorrow we'll finish the new material. Friday we'll kind of wrap that new material. Monday will be the primary exam review. And Tuesday they're in lesson 44 taking your exam up through graphing sine and cosine. We'll have to save all the other graphs like tangent, secant, cosecant, all that for after the exams. Those will not be on the exam. All right, when the bell rings, you'll be dismissed. Have a wonderful rest of your day.